everyone. This is the video for the solutions to review sheet number 2. And primarily in this review sheet, we're going to talk about polynomial and rational functions, how to graph them, just review of graphing, and different things having to do with those. So in this first problem, we're kind of working backwards. We're actually given the roots, and we're being asked to find the equation that has those roots. So if we look at problem A, or part A, if I know that those are my roots, like I said, I'm just working backwards. That must mean that x plus 1 is a factor, x minus 2 is a factor, and x plus 3 equals 0 is a factor. And from there, then I just need to multiply those together. So x plus 1 times x minus 2 times x plus 3 is equal to 0. I would multiply the first two together first. That gives you x squared minus x minus 2. Multiply that by x plus 3. And you end up with x cubed, plus 3x squared minus x squared minus 3x minus 2x minus 6. And if you combine your like terms, we end up with x cubed plus 2x squared. When I combine those two terms, 2x squared minus 5x minus 6, and that would be your function f of x. Make sure that you write an equation, otherwise you will lose a point there. Okay. A quick thing before I go on to the next one here. Remember that if there are problems with roots where some of the roots are either irrational or imaginary or complex, then you need to make sure you include the conjugate pair as part of your solution. So let's say, for example, in part B here, that one of my roots was also x is equal to 4i, and that's all they told you. Then you know that you do still have another root, and that would be x equals negative 4i, because those are conjugate pairs. So if they only give you one, recognize that there actually are two other roots there, or there's two roots total, the one and its conjugate pair. Okay, so part B is really the same as part A. That would give us x minus 2 equals 0, x plus 2 equals 0, and x plus 5/2 is equal to 0. And a lot of people freak out when they see fractions. They don't like working with fractions. But it's really not that bad, right? When you multiply these together, those are conjugate pairs. That gives you x squared minus 4. And then you're just multiplying that by x plus 5/2. And so that would just give you x cubed plus 5/2 x squared minus 4x minus 20/2, or 10 there. Okay, and that would be equals f of x. So pretty straightforward on those. Remember, like I said, if they throw in an imaginary root, make sure you do that and its conjugate. Same if it is a complex root or an irrational root. So just a quick example, if one of the roots they gave you was x was equal to 3 plus radical 2, then you know the other root has to be 3 minus radical 2. And so when you're figuring out the linear factors, that would mean that x minus 3 plus radical 2 was a factor, and x minus 3 minus radical 2 was also a factor. So it just gets a little bit messier, but it's still the same process of doing it. Okay, you're still going to FOIL everything. Okay, in this one, they told you that -3 was a root, and it says to find the other roots in factored form. Now, remember, this is not factorable because even though there's 4 terms, the product of the middle terms doesn't equal the product of the outside terms. So I would use synthetic division. Because I know that -3 is one of my roots, then I can find my other roots by finding the sort of decompressed version of this. So if I use synthetic division, I end up with 1, -7, -5, and 75. And let's see that -1 or 1 times -3 is -3. That gives me -10. That gives me +30, 25. -75 and 0, which I knew that would come out to be 0 because it said -3 is a root. But now, if you look at what you have left, this is now your new polynomial function, right? This would then be x squared minus 10x plus 25, and that we know we can factor. That factors to x minus 5 and x minus 5. And so my other root then is just 5. Now, just a quick review, right? When a root comes up more than once, that talks about multiplicity. So this has a multiplicity of 2, and that means when you're graphing it, it touches the x-axis at 5 and turns around. If it has an odd multiplicity, it just passes through the x-axis, and that's actually going to help us in this next problem. It says if you have the graph, write the function in factored and standard form. Well, all we have to do is find our zeros. This is a 4th degree polynomial, which I know that because I'm crossing the x-axis 4 times. And every single time I'm just passing through there. So I have there, 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 and there. So that was 1, 2, 3, 4, 5, 6, 7, 8. So my roots are at 8, or excuse me, -8, -4, 1, and 3. Which means x equals -8, x equals -4, x equals 1, and x equals 3. And so x plus 8 is a factor, x plus 4 is a factor, x minus 1 is a factor, and x minus 3 is a factor. Okay, so that is my function in factored form, and then in standard form I just have to multiply them out. So this first part would give me x squared plus 12x plus 32. And the second part would give me x squared minus 4x plus 3. And then if I multiply those together, x to the 4th minus 4x cubed plus 3x squared plus 12x squared minus 48x, that was cubed, sorry, this should have been cubed, 48x squared plus 36x, let's see, plus 32x squared minus 118, or 128x plus 96. Okay, and then when we combine our like terms, let's see, we have x to the 4th, then 4x, -4x cubed, and 12x cubed would give me 8x cubed. I took care of that already. 3x squared minus 48x squared is -45 plus 32 would be -13x squared. I think that's right. Yep. Okay, and 36x and -128 would give me -14x 92 x and plus 96. So I think I got everything in there. I think I got it all. Hopefully I didn't make a little careless math mistake in there, but that's how you would go about doing that. Okay. Same idea with letter B. In letter B here, we have 3 roots. And the reason I know it's 3 is because here I'm touching the x-axis and I turn. That means it has a multiplicity of 2. So at 1, 2, 3, 4, 5, 6, at x equals 6, I have a multiplicity of 2. That means x equals 6 and x equals 6 are roots. And then also x equals -2. And from there, I would go through the same process I did over here. So I end up with x plus 2 times x plus 6 times x plus 6. And that would give me x squared plus 8x plus 12 times x plus 6, which would give me x cubed plus 6x squared plus 8x squared plus 48x plus 12x plus 72. So my final answer there, I'll do this in another color, f of x would equal x cubed, let's see, plus 14x squared plus 60x plus 72, assuming I did all my arithmetic correctly. All right, so that's the idea behind how to do those problems. The next part is going through the process of graphing different polynomial functions. So we'll start with this one. I might not finish the whole problem in this video, but I'll definitely finish it up in the next one. So the first thing I want to talk about is symmetry. Remember, symmetry, you have y-axis or origin. Symmetry are the only 2 possibilities. In this case, I do not have either because of the fact that I have even and odd exponents in there. Okay, the second thing is I want to figure out my end behavior. And because my graph, because my equation has an even exponent and a positive leading coefficient, that means both ends are up. The next thing is the y-intercept, so we'll figure that out. Remember, that's just figuring out what f of 0 is equal to, and that would be 4. And the next part is figuring out the x-intercepts. And here is where we would have to do our possible rational roots and go through synthetic division. So I'm going to actually stop the video there, and then I'll pick up with the rest of this problem starting in the next video. Okay, thanks folks.